Table 310.15b6 has been a part of the National Electrical Code since 1937. The origin of this table is based on several assumptions. Firstly, dwellings have lighter electrical loads compared to commercial or industrial buildings. Secondly, dwellings are less likely to have continuous or heavy-duty loads. Thirdly, dwellings typically have more space available for heat dissipation from electrical conductors. These assumptions were re-evaluated and considered valid as recently as 1993 when the Electrical Safety Foundation International, or SV, published a report examining the impact of insulation on conductor ampacity in residential branch circuits. The SV report concluded that the temperature increase in conductors within residential branch circuits isn't significantly influenced by the type of insulation used, provided the conductors are correctly installed. Now, concerning the temperature exceeding 60 degrees Celsius or 140 degrees Fahrenheit for conductors, the 60 degrees Celsius limit is tied directly to the insulation rating of the specific conductors being used. Type TW conductors, for example, are rated for a maximum operating temperature of 60 degrees Celsius. If these conductors are loaded up to their maximum allowed ampacity, the temperature can indeed rise above 60 degrees Celsius, potentially causing damage to the insulation over time. It is generally true that dwellings do not usually load their electrical services to their maximum capacity. However, it is also important to recognize that this isn't always the case. A dwelling equipped with an electric heat pump or a large number of appliances can easily draw power close to the maximum service rating. Therefore, it is a potentially dangerous assumption to believe that dwellings will never load their services to the maximum. Relying on such an assumption could lead to the installation of undersized conductors, which in turn can overheat and increase the risk of electrical fires. In conclusion, while Table 310.15b6 is rooted in reasonable assumptions about the typical electrical loading of dwellings, it's crucial to acknowledge that dwellings can, under certain circumstances, draw power up to their maximum service rating. Consequently, it is critically important to ensure that conductors are always properly sized for the actual anticipated load to prevent overheating and potential hazards. Electrical installations must comply with all applicable codes and standards, including proper conductor sizing based on load calculations and ampacity ratings. It is crucial to perform accurate load calculations to determine the appropriate conductor size. Consider all connected loads, including lighting, appliances, heating, and cooling systems. Apply appropriate demand factors as permitted by the National Electrical Code to account for non-simultaneous operation of loads. Select conductors with an ampacity rating equal to or greater than the calculated load current. Ensure that the selected conductors meet the requirements of Table 310.15b6 or other applicable tables in the National Electrical Code. Account for ambient temperature and conductor deterring factors as specified in the National Electrical Code. Properly install and terminate conductors in accordance with manufacturer instructions and industry best practices. Regularly inspect electrical systems to identify and address any potential issues, such as overloaded circuits or damaged conductors. When working with electrical systems, always prioritize safety and follow established safety protocols, including de-energizing circuits before working on them. Seek guidance from qualified electrical professionals if you have questions or concerns about electrical installations or safety. Understanding the historical basis and limitations of Table 310.15b6 is essential for electrical professionals to ensure safe and reliable electrical installations in dwelling units. The correct application of the National Electrical Code, including proper conductor sizing and load calculations, is crucial to prevent electrical hazards. Always consult the latest edition of the National Electrical Code and seek guidance from qualified electrical professionals to ensure compliance with applicable codes and standards. The National Electrical Code is updated regularly to reflect advancements in electrical technology and safety practices. Staying informed about the latest changes and updates to the National Electrical Code is essential for electrical professionals to maintain competency and ensure compliance. The National Electrical Code provides comprehensive guidelines for electrical installations, including conductor sizing, overcurrent protection, grounding, and bonding. Adhering to the National Electrical Code helps minimize the risk of electrical hazards such as fires, shocks, and equipment damage. Electrical inspections are an important part of the electrical safety process. Electrical inspectors verify that electrical installations comply with the National Electrical Code and other applicable standards. Passing an electrical inspection is essential to ensure the safety and reliability of electrical systems. Electrical safety training is essential for anyone working with electrical systems. Electrical safety training provides individuals with the knowledge and skills necessary to identify and avoid electrical hazards. Completing electrical safety training can help prevent electrical accidents and injuries. Electrical work should only be performed by qualified and licensed electricians. Qualified electricians have the training, experience, and expertise necessary to perform electrical work safely and correctly. Hiring a qualified electrician helps ensure that electrical installations are performed in accordance with applicable codes and standards. Electrical permits are often required for electrical work, especially for new installations or modifications to existing systems. Obtaining an electrical permit ensures that the work will be inspected by a qualified electrical inspector. Following proper procedures for obtaining electrical permits helps ensure compliance with local regulations. The overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Properly sized overcurrent protection devices are essential to prevent electrical fires and equipment damage. Replacing overcurrent protection devices with high-rated devices can create a serious safety hazard. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Regular maintenance of electrical systems is essential to ensure their continued safety and reliability. Regular maintenance includes inspecting conductors, connections, and overcurrent protection devices. Addressing any identified issues promptly can prevent electrical hazards and equipment damage. Electrical emergencies can occur at any time. Knowing how to respond to electrical emergencies, such as electrical fires or shocks, is essential for safety. Always call emergency services immediately in the event of an electrical emergency. Electrical safety is everyone's responsibility. By following safe electrical practices and being aware of potential hazards, individuals can help prevent electrical accidents and injuries. Promoting electrical safety awareness in homes, workplaces, and communities can help create a safer environment for everyone. The information presented here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific electrical design and installation requirements. The National Electrical Code is a complex and comprehensive document. It is essential to consult the latest edition of the National Electrical Code and other applicable standards for accurate and up-to-date information. Electrical technology is constantly evolving. Staying informed about the latest advancements in electrical technology can help electrical professionals provide safer and more efficient electrical systems. Electrical sustainability is becoming increasingly important. Implementing energy-efficient electrical designs and practices can help reduce energy consumption and minimize environmental impact. Electrical codes and standards are developed and maintained by organizations such as the National Fire Protection Association, or NFPA, and the International Code Council, or IC. These organizations work to ensure that electrical codes and standards reflect the latest safety practices and technological advancements. Compliance with electrical codes and standards is essential for protecting people and property from electrical hazards. Ignoring electrical codes and standards can lead to serious consequences, including fines, liability, and potential harm to individuals. Electrical inspections are typically conducted by local government agencies or third-party inspection organizations. Electrical inspectors are trained to identify electrical hazards and ensure compliance with applicable codes and standards. Passing an electrical inspection is often required before a new or modified electrical system can be put into service. Electrical safety programs are often implemented in workplaces to promote electrical safety awareness and prevent electrical accidents. Electrical safety programs may include training, inspections, and hazard assessments. Effective electrical safety programs can help reduce the risk of electrical injuries and fatalities. Electrical lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the equipment from its power source and applying a lock or tag to prevent it from being re-energized. Following proper lockout/tagout procedures is essential for preventing electrical accidents during maintenance or repair activities. Electrical personal protective equipment, or PPE, is used to protect workers from electrical hazards. Electrical PPE may include insulated gloves, sleeves, and footwear. Using the appropriate electrical PPE is essential for reducing the risk of electrical shock and burns. Electrical arc flash hazards are a serious concern in electrical workplaces. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. Arc flash can cause severe burns, blindness, and even death. Electrical arc flash hazard assessments are used to determine the level of risk associated with electrical equipment. Arc flash hazard assessments help identify the appropriate PPE and safe work practices for working on or near energized electrical equipment. Electrical safety audits are conducted to assess the effectiveness of electrical safety programs and identify areas for improvement. Electrical safety audits may be conducted by internal staff or external consultants. Implementing recommendations from electrical safety audits can help improve electrical safety performance. Electrical safety culture is an important aspect of overall safety management. An electrical safety culture is a shared commitment to electrical safety among all employees. Promoting an electrical safety culture can help reduce the risk of electrical accidents and injuries. Electrical safety training should be provided to all employees who work with or near electrical equipment. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of electrical PPE. Effective electrical safety training can help employees understand the risks associated with electrical work and how to protect themselves. Electrical safety meetings are a useful tool for communicating electrical safety information to employees. Electrical safety meetings can be used to discuss recent electrical incidents, review safe work practices, and reinforce the importance of electrical safety. Holding regular electrical safety meetings can help keep electrical safety top of mind for employees. Electrical safety posters and signage can be used to remind employees of electrical hazards and safe work practices. Electrical safety posters and signage should be placed in prominent locations where they will be seen by employees. Using clear and concise language on electrical safety posters and signage can help ensure that the message is understood. Electrical safety alerts and bulletins can be used to communicate urgent electrical safety information to employees. Electrical safety alerts and bulletins should be distributed promptly to all affected employees. Providing timely and accurate electrical safety information can help prevent electrical accidents and injuries. Electrical safety investigations should be conducted following any electrical incident. Electrical safety investigations should identify the root cause of the incident and develop recommendations for preventing similar incidents from occurring in the future. Conducting thorough electrical safety investigations can help improve electrical safety performance and prevent future accidents. Electrical safety performance should be monitored and tracked to identify trends and areas for improvement. Electrical safety performance metrics may include the number of electrical incidents, the number of electrical safety audits conducted, and the percentage of employees who have completed electrical safety training. Tracking electrical safety performance can help organizations identify areas where they need to focus their efforts to improve electrical safety. Electrical safety is a continuous process that requires ongoing effort and attention. By implementing effective electrical safety programs, providing comprehensive electrical safety training, and promoting a strong electrical safety culture, organizations can help reduce the risk of electrical accidents and injuries and create a safer work environment for everyone. Always refer to the latest edition of the National Electrical Code, or NEC, and local electrical codes for specific requirements related to electrical installations. Remember that this overview provides general information and should not be used as a substitute for consulting with qualified electrical professionals for specific projects or situations. The information provided here does not cover all aspects of electrical safety and should not be considered a complete or exhaustive guide. Always consult with qualified electrical professionals for specific electrical design, installation, and safety requirements. Electrical work can be dangerous and should only be performed by qualified and licensed electricians. Never attempt to perform electrical work if you are not properly trained and qualified. Always prioritize safety when working with electricity. Following safe electrical practices and being aware of potential hazards can help prevent electrical accidents and injuries. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. Compliance with the National Electrical Code is essential for ensuring electrical safety. The National Electrical Code is updated every 3 years to reflect advancements in electrical technology and safety practices. Staying informed about the latest changes and updates to the National Electrical Code is essential for electrical professionals to maintain competency and ensure compliance. The National Fire Protection Association, or NFPA, is the organization that publishes the National Electrical Code. The National Fire Protection Association also develops and publishes other codes and standards related to fire safety and electrical safety. The International Code Council, or ICE, is another organization that develops and publishes built-in codes and standards. The International Code Council's International Building Code, or ICE, includes provisions related to electrical safety. Local jurisdictions may adopt and amend the National Electrical Code or other built-in codes to meet the specific needs. It is important to be aware of the local electrical codes and regulations that apply in your area. Electrical permits are often required for electrical work, especially for new installations or modifications to existing systems. Obtaining an electrical permit ensures that the work will be inspected by a qualified electrical inspector. Following proper procedures for obtaining electrical permits helps ensure compliance with local regulations. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations comply with applicable codes and standards. Passing an electrical inspection is essential to ensure the safety and reliability of electrical systems. Electrical inspectors are trained to identify electrical hazards and ensure compliance with applicable codes and standards. Electrical safety training is essential for anyone working with electrical systems. Electrical safety training provides individuals with the knowledge and skills necessary to identify and avoid electrical hazards. Completing electrical safety training can help prevent electrical accidents and injuries. Electrical work should only be performed by qualified and licensed electricians. Qualified electricians have the training, experience, and expertise necessary to perform electrical work safely and correctly. Hiring a qualified electrician helps ensure that electrical installations are performed in accordance with applicable codes and standards. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific electrical design and installation requirements.